Good morning, everyone. This is B. Ramarao from Government Polytechnic College, Station Ganpur. Today, our topic coordinate covalent bond and oxidation number. These topics discussed in first year diploma student for first semester syllabus. What is coordinate covalent bond? How to form coordinate covalent bond in some molecule? What is oxidation number? How to calculate the oxidation number of atom in the molecule? These topics we discuss in this hour. Objectives. Objectives on this topic. Objectives. On the completion of this period, you would be able to know what is covalent bond, what is coordinate covalent bond, how to form coordinate covalent bond in between molecule, what is oxidation and reduction, what is oxidation number, how to calculate the oxidation number in atom in the molecule. Find the oxidation number of atom in a molecule. Find the oxidation number of atom in a molecule. These topics discussed in this hour. What is coordinate covalent bond? What is coordinate covalent bond? What is coordinate covalent bond? A coordinate covalent bond is a covalent bond formed between two atoms in which the shared pair of electrons. Two electrons mutual contribute sharing with each other is called covalent bond. Here, sharing pair of electrons is contributed by one of the atom in the molecule is called coordinate covalent bond. A coordinate covalent bond is a covalent bond, but these two electrons bond given by one of the involving atom or molecule is called coordinate covalent bond. A coordinate covalent bond is a covalent bond formed between two atoms. Formed between two atoms in which the shared pair of electrons is contributed by only one of the atoms. The atom providing the electron pair is called donor atom. The atom which accepts the electron pair is called acceptor atom. A coordinate covalent bond is donated by an arrow pointing towards the acceptor atom, which is two electrons donate to another atom, then form a covalent bond is called coordinate covalent bond. These two electrons contributed by one of the atom in the molecule is called coordinate covalent bond. The atom providing the electron pair is called electron pair donor atom. The atom which accepts the electron pair is called the acceptor atom. A coordinate covalent formed between two atoms, one is acceptor atom and another one is donor atom. A coordinate covalent bond is denoted by an arrow pointing towards the acceptor atom. Pointing towards the acceptor atom. A coordinate covalent bond is a covalent bond formed between two atoms in which the shared pair of electron is contributed by only one of atom. Is called coordinate covalent bond. The covalent bond. What is covalent bond? Sharing of two electrons between the atoms is called covalent bond. The covalent bond formed by sharing electrons of pair of electron contributed by one of the bonded atom. One of the bonded atoms is called coordinate covalent bond or dative bond. Coordinate covalent bond is formed by overlapping the doubly filled orbital with an empty orbital of another atom. With an empty orbital of another atom. The atom which contributes electron pair for sharing is called donor atom, and the atom which accepts the electron pair is called acceptor atom. Donor atom has lone pair of electrons and acceptor atom has empty orbital. Coordinate covalent bond is represented by arrow pointing towards acceptor atoms from donor atom. The properties of coordinate compounds are intermediate between ionic compounds and covalent compounds. The properties of coordinate covalent compounds are intermediate between ionic compounds and covalent compounds. Like example, formation of coordinate covalent bond in ammonia and boron trifluoride, ammonia and boron trifluoride, ammonium ion NH4 plus, hydronium ion H3O plus, SO2, SO3, so on. Coordinate covalent bond formation in between condition for the formation of coordinate covalent bond. First condition, the donor atom should have a lone pair of electrons. Condition for the formation of coordinate covalent bond. First condition, the donor atom should have a lone pair of electrons. The donor atom should have a lone pair electron. Second point, the acceptor atom should have a vacant orbital to accept the electron pair donated by donor. The donor should have lone pair of electrons. The acceptor should have a vacant orbital to accept the electron pair donated by donor. The atom which contributes electron pair for sharing is called donor atom, and the atom which accepts the electron pair is called acceptor atom. Donor atom has lone pair of electrons and acceptor atom has empty orbital. One atom have pair of electron present on central atom and another atom have vacant orbital on central atom. The pair of electrons transfer from donor to acceptor. It is represented by arrow mark. Now here given one example, combination of ammonia and boron trifluoride. The nitrogen atom in ammonia has a full outer shell inclusive of a lone pair which it can donate. Ammonia contains one lone pair on nitrogen atom. In ammonia formed between one nitrogen atom and three hydrogen atoms. In nitrogen electronic configuration 1s2, 2s2, 2p3. So in its valence one pair of electrons and three unpair of electrons are available. These three unpair of electrons shared with three hydrogen single electrons then form three covalent bonds between nitrogen and hydrogen. In nitrogen on central atom present one pair of electrons, three bonded electrons. So it is valency electrons, 8 electrons, octet configuration, then it is stable. The boron atom. The boron atom. In boron trifluoride, is short of 2 electrons in its valence, which it accepts to attain a full outer shell. So here boron trifluoride, boron in its valency shell have 3 electrons. These 3 electrons and one empty orbital present in its valency. 2s 1 electron, 2px 1 electron, 2py 1 electron, and 2pz is empty orbital. Here 3 electrons are available in its valency shell. Those 3 electrons combined with fluorine uncombined electrons then form boron and fluorine between 3 covalent bonds form and also have one empty orbital in its valency shell. According to coordinate covalent bond, according to coordinate covalent bond formed by sharing electron pair contributed by one of the bonded atom. Sharing of two electrons between atom given by one of the bonding atom is called coordinate covalent bond. Here ammonia contains one lone pair of electrons on central atom of nitrogen atom, and boron atom contains one vacant orbital. Nitrogen atom contributes lone pair to boron in boron trifluoride, then form a coordinate covalent bond between ammonia and boron trifluoride. Ammonia and boron trifluoride. Nitrogen of ammonia contains one electron pair, so ammonia acts as electron pair donor. Electron pair donor. Boron of boron trifluoride contains a vacant orbital in the valency orbit. So, boron trifluoride acts as acceptor. Hence, a coordinate covalent bond is formed between ammonia and boron trifluoride. Ammonium ion. Ammonium ion. This ammonium ion formed between the reaction of ammonia and hydrogen ion. Ammonia and hydrogen ion. It is formed by the combination of the ammonia molecule and hydrogen ion. Hydrogen ion, that means H plus ion. In ammonia, the nitrogen atom has pair of electrons after completing its octet. It donates this lone pair to the hydrogen ion. Thus, the nitrogen atom becomes the donor, the hydrogen atom becomes the acceptor. The linkage between nitrogen and hydrogen atom is called coordinate covalent bond. It is represented by an arrow mark. In ammonium ion formed between ammonia and hydrogen ion. Nitrogen of ammonia contains a lone pair of electrons, so ammonia acts as donor, H plus ion acts as acceptor. So a coordinate covalent bond formed between ammonia and hydrogen ion. Here see the reaction between ammonia and hydrogen ion. Ammonia. One nitrogen atom, three hydrogen atoms. In nitrogen atom, in its valency present one lone pair of electrons, three unpaired electrons. These three unpaired electrons combined with three hydrogen atoms then form three covalent bonds, and also present one lone pair of electrons. Here ammonia acts as pair of electron donor, hydrogen present in its valency only one electron, then loss of one electron it form hydrogen ion. This hydrogen ion present 1s0, so empty orbital present in its valency cell. These H plus ion act as electron pair acceptor. Ammonia donor, H plus ion acceptor. This pair of electrons transfer from nitrogen to hydrogen empty orbital. Then form a coordinate covalent bond between ammonia and hydrogen ion. These two electron covalent bond contributed by one of the nitrogen atom is called coordinate covalent bond. Shared electron pair given by one of the bonding atom. Here ammonia and H plus ion formed between a coordinate covalent bond is called ammonium ion. Ammonia NH3, this arrow mark represented from nitrogen to hydrogen. These nitrogen act as donor, hydrogen act as acceptor. Hydronium ion. This hydronium ion formed between water molecule and hydrogen ion. Here in water molecule formed by between one oxygen atom to hydrogen atoms. In oxygen in its valency present two lone pair of electrons to unpaired electrons. These unpaired electrons shared with two hydrogen atoms then form a stable molecule of water. Hydrogen ion present one empty orbital in its valency cell. It is act as electron pair acceptor. Water molecule act as electron pair donor. One pair of electrons donate to water molecule to hydrogen ion. Then form a coordinate covalent bond between water and H plus ion. See here reaction oxygen to hydrogen atoms, two lone pair of electrons plus H plus ion, then one pair of electrons transfer from oxygen to H plus ion, then form a coordinate covalent bond. Here arrow marks here oxygen to H plus ion, then oxygen act as donor, H plus ion act as acceptor. The oxygen atom in water molecule has two lone pair of electrons. It donates one pair to the hydrogen ion. Oxygen is thus electron pair donor, hydrogen ion acceptor. The hydrogen ion carries over its charge to the hydronium ion. Now, what is oxidation and reduction? What is oxidation and reduction? Redox reaction. What is redox reaction? Are chemical reactions involve simultaneously oxidation and reduction process. Simultaneously oxidation and reduction involved in a reaction is called redox reaction. A reaction which involves simultaneous oxidation and reduction is called redox reaction. Redox reaction are a chemical reaction involving simultaneously oxidation and reduction process. A reaction which involves simultaneous oxidation, and reduction is called redox reaction. What is oxidation? The reaction in which an atom or ion or molecule loss of electrons is called oxidation. Here given some example: sodium loss of electron in its valency, then form Na plus 1 electron is called oxidation reaction. Magnesium loss of 2 electrons, then form Mg plus 2 electrons. Fe loss of 3 electrons, then form Fe plus 3 electrons. These all are oxidation reactions. Loss of electrons from the atoms is called oxidation, or addition of oxygen or removal of hydrogen is also called oxidation. Accepting or donating of electrons. Change the oxidation number. Increasing of oxidation number is called oxidation. Addition of oxygen like Mg plus O2 gives MgO2 is called oxidation. What is oxidation? The reaction in which an atom loss of electrons is called oxidation. Second one, addition of oxygen or removal of hydrogen is called oxidation. Third one, increasing in oxidation number is called oxidation. Now, reduction. What is reduction? The reaction in which an atom, ion or molecule gain of electrons is called reduction. Like Na plus gain of 1 electrons to form Na. This one is redox reaction. Reduction reaction. The reaction in which an atom gain of electrons is called reduction. Na plus gain of 1 electrons to form Na. This reaction is reduction reaction. Or addition of hydrogen or removal of oxygen is called reduction. Addition of hydrogen or removal of oxygen is called reduction. Decreasing in oxidation number is called reduction. Decreasing in oxidation number is called reduction. So here oxidation and reduction simultaneously in a single reaction is called redox reaction. Redox reaction. Oxidation is the process of gaining oxygen or elimination of hydrogen. Reduction is the process of losing oxygen and addition of hydrogen. Oxidizing agent is the substance which experiences reduction and receives electrons. Reducing agent is the substance which experiences oxidation and donates electrons is called reduction. Oxidation is nothing but loss of electrons. Here given reaction Mg plus Cl2 gives MgCl2. Each magnesium atom loss of 2 electrons to form magnesium ion. Mg gives Mg plus 2 electrons. In this reaction, magnesium atom has been oxidized to form magnesium ion. Transfer of electrons between the atoms. Transfer of electrons. Oxidation involves the loss of electrons. Reduction involves a gain in electrons. Gain in electrons. Oxidation involves the loss of electrons. Reduction involves a gain in electrons. Metals are oxidized, its loss their electrons to form cation. Non-metals are reduced, its receive electrons to form anions. Here given one example, sodium plus Cl2 gives 2NaCl. 2Na plus Cl2 gives 2NaCl. 2NaS means sodium in solid state. The sodium loss of electrons in its valence shell to form Na plus 1 electron. Na gives Na plus 1 electrons. This loss of electron is nothing but oxidation reaction. This oxidation involves in sodium atom and chlorine gas. Chlorine gain of electrons from sodium atoms. Then forms Cl2 plus 2 electrons gives 2Cl minus. Gain of electrons is called reduction process. Oxidation takes place at sodium atom and reduction takes place in chlorine atom. These both transfer of electrons from sodium to chlorine atom then form a stable ions of Na plus Cl minus ions react together to form a stable molecule of sodium chloride in solid state. Here sodium atom loss of electrons in its valence shell is act as oxidation reaction. The sodium act as reducing agent. Reducing agent. Which atom undergoes to oxidation is act as reducing agent. In chlorine, gain of electrons from sodium atom to form chlorine anion. This reaction is called reduction reaction. Which atom undergoes to reduction is act as oxidizing agent. Oxidizing agent. Introduction. Oxidation is loss of electron. Reduction is gain of electrons. Substances that causes oxidation are called oxidizing agent, which causes oxidation are called oxidizing agent. For example, O2, Cl2, so on. Substance that causes reduction are called reducing agent. For example, H2, C, CO, so on. The number of electrons an atom appears to have gain or loss. The number of electrons an atom appears. So sodium loss of 1 electrons, it appears in A place. Magnesium loss of 2 electrons, then form Mg plus 2. Chlorine gain of electrons, it chooses Cl minus. Oxygen gain of 2 electrons from another atom, then it chooses O minus 2. This charge is called oxidation number. The charge that would appear on the atom of element. The charge that would appear on the atom of element in combined state is called oxidation number or oxidation state. The charge that would appear on atom of element in combined state is called oxidation state or oxidation number. Rules for calculation of oxidation number. Rules for calculation of oxidation number. First rule. In free elements, the oxidation number is 0. The atom does not involving in any chemical reaction, that oxidation number is 0. Sodium oxidation number 0, copper oxidation number 0, phosphorus 0, aluminum 0, magnesium 0. The free elements is an atom on its own. It is neutral, so it is have neither loss of electrons or gain of electrons. That one is first rule. Second one is the sum of all the oxidation number is 0. The sum of atoms, all the oxidation number is 0. Here calcium oxidation number, carbon oxidation number, 3 oxygens oxidation number is equal 0. CaCO3, 1 calcium, 1 carbon, 3 oxygens oxidation number is equal 0. Ammonium sulfate, here 2 nitrogen atoms, 8 hydrogen atoms, 1 sulfur, 4 oxygen oxidation number is equal 0. Third one, the oxidation number of a simple ion is the charge on that ion. The oxidation number of simple ions is equal to its charge. Na plus, its oxidation number is equal to plus 1. Ca plus 2, its oxidation number plus 2. N minus 3, oxidation number minus 3. Cl minus, oxidation number minus 1. O minus 2, oxidation number minus 2. Al plus 3, its oxidation number plus 3. S minus 2, its oxidation number minus 2. The sum of oxidation number in a complex ion is the charge on ion. Complex ion. Here SO4 minus 2. The sum of ions oxidation number, atoms oxidation number ions is equal to its charge. 1 sulfur, 4 oxidation number is equal minus 2. S plus 4 oxygens is equal to minus 2. PO4 minus 3, 1 phosphorus, 4 oxygens is equal to minus 3. 1 nitrogen plus 4 hydrogen oxidation number is equal to plus 1 in ammonium ion. Nitrate ion, 1 nitrogen plus 3 oxygen is equal to minus 1. The compound containing hydrogen, the oxidation number of hydrogen is plus 1. Hydrogen oxidation number is plus 1. H2O, HCl, NH4 plus, CH3COH, here hydrogen oxidation number plus 1. In case these hydrogen combined with first and second group element, its oxidation number minus 1. Like sodium hydride, here hydrogen oxidation number minus 1, sodium plus 1. Potassium hydride, hydrogen minus 1, potassium plus 1. In compounds containing oxygen, the oxidation number of oxygen is -2. General oxygen oxidation number -2. In peroxides, its oxidation number -1. Hydrogen peroxide, sodium peroxide, barium peroxide. Here oxygen oxidation number -1. In fluorides, its oxidation number +1 and +2. Oxygen difluoride, dioxygen difluoride. OF2, O2, F2. The alkali metals are always +1 in a compound. The first group elements always show +1 oxidation state. Those elements are lithium, sodium, potassium, rubidium, cesium, francium. These atoms oxidation number +1. First group elements oxidation number always +1. Those atoms are lithium, sodium, potassium, rubidium, cesium, francium. The alkaline earth metals are all +2 its oxidation number. The second group elements always show +2 oxidation state. Those are beryllium, magnesium, calcium, strontium, barium, radium. The alkaline earth metals, that is second group elements, oxidation number +2. Beryllium, magnesium, calcium, strontium, barium, radium. The halogens, oxidation number -1. Seventh group elements oxidation state always -1. Those are fluorine, chlorine, bromine, iodine. When bonded to more electronegativity atoms, the oxidation number plus positive. Chlorine monoxide, chlorine oxidation state +1. Chlorine dioxide, chlorine oxidation state +4. Oxidation is a decreases in oxidation number. Reduction is again oxidation number. Here Mg plus U plus 2 gives Mg plus 2 plus C. Mg has oxidation number 0, 2 plus 2, loss of 2 electrons. Copper has reduced oxidation number +2 to 0, gain of 2 electrons. Sodium oxide, Na2O. Na2O. Here sodium, first group element, this element oxidation number +1. Oxygen oxidation number -2. Sodium +1 into 2 plus oxygen is equal 0 plus 2 plus oxygen is equal 0, then oxygen is equal -2. Here KMnO4 manganese oxidation number overall 0, 1 potassium, 1 manganese, 4 oxygens is equal 0. Potassium present in first group element, its oxidation number +1, oxygen general oxidation state -2, then 1 potassium is equal +1 plus Mn plus 4 into -2 is equal 0, 1 plus Mn -8 is equal 0, then Mn -7 is equal 0, Mn is equal plus 7. This one is calculation of manganese oxidation state in KMnO4. Right here, differences between oxidation number and valence. Oxidation number. The charge of an atom or a pair have to molecule or ion is called oxidation number. The charge that would appear an atom in a molecule is called oxidation number. Valency. The number of electrons lost or gained or shared by an atom is called valency. It may be integral or fraction. Oxidation may be integral or fraction. Valency. It is always integral only. Oxidation number. It may be positive or negative value. Valency. No positive or negative sign for valence. Oxidation number. An atom may have 0 oxidation number in the compound. An atom has never 0 valency in the compounds. These are differences between oxidation number and valency. Frequently asked questions about these topics. First one is define coordinate covalent bond. Frequently asked questions about this topic. Define coordinate covalent bond. Second one is explain formation of coordinate covalent bond in molecules. Calculate the oxidation number of manganese and chromium in KMnO4 and K2Cr2O7. Write the difference between oxidation number and valence. First one is define coordinate covalent bond. Explain formation of coordinate covalent bond in molecules like ammonia and boron trifluoride, ammonium ion, hydronium ion, NH3 and boron trifluoride. Ammonium ion, it formed between ammonia and hydrogen ion. Hydronium ion formed between water molecule and hydrogen ion. Calculate the oxidation number of KMnO4, K2Cr2O7 in manganese and chromium oxidation number. How to calculate the chromium oxidation number? 2 potassium, 1 chromium, 7 oxygens is equal 0. Potassium present in first group, 2 into 1 that is equal 2 plus Cr, 7 into minus 2 is equal 0. 2 plus Cr minus 14 is equal 0. 2 plus 2Cr plus 14 is equal 0. 2Cr minus 12 is equal 0. 2Cr is equal 12. Cr is equal 12 by 2. That is equal 6. Write the difference between oxidation number and valency. Thank you once again.